Hello, good morning, welcome to today's stream. We're doing day 8 of Advent of Code. Thanks for joining. Today I'm trying something a little different. As you may have noticed, the background music. I'm hoping this makes the channel a little bit more entertaining to watch. I hope it's not too loud or too soft. Let me know in the chat if the volume is good with a thumbs up. Then we can continue. I have everything set up here. Made a folder for day 8, an index.js file with some setup code. And today I'm also trying a new theme because the previous theme I was using, the syntax highlighting did not have that high of a contrast, so it was a bit hard to read in some parts. Watchers have said so. I've switched to this one, so there's a lot of red in here. I'm gonna pull up the yesterday solutions. Lots of red, orange, so definitely some getting used to it, but it's much higher contrast, so I hope this is gonna be good for today. I hope the sound is fine. If during the stream it gets too loud or too soft, the music, let me know. So I'm gonna go ahead and start with day 8. Let's see what today is about. I'm exciting. This is the first time I'm reading as well along with you folks. Handheld halting. I believe we're in a second airplane right now, because we started on top of the mountain, went down with a sled, toboggan as they call it, and then we were at the airport. Then we flew to an island, seems like it. We flew to an island where we transferred to an international flight, because the first one was a regional flight. So I think now we're aboard a second flight. All right, so the story goes: handheld halting. Your flight to the major airline hub reaches cruising altitude without incident. That's good. While you consider checking the in-flight menu for one of those drinks that come with a little umbrella, a cocktail, you are interrupted by the kid sitting next to you. Their handheld game console won't turn on. So I guess like a Nintendo, yeah. They ask if you can take a look. Great. You narrow the problem down to a strange infinite loop in the boot code, your puzzle input. So the boot code is going to be the puzzle input of the device. You should be able to fix it, but first you need to be able to run the code in isolation. The boot code is represented as a text file with one instruction per line of text. Each instruction consists of an operation, ACC, GMP, or NOP, and an argument, a signed number like +4 or -20. ACC increases or decreases a single global value called the accumulator by the value given in the argument. For example, ACC +7 would increase the accumulator by 7. That makes sense. The accumulator starts at 0. After an ACC instruction, the instruction immediately below it is executed next. So after we see an ACC, the instruction immediately below it is executed next. Okay, makes sense. GMP stands for jumps to a new instruction relative to itself. The next instruction to execute is found using the argument as an offset from the GMP instruction. For example, jump 2 would skip the next instruction. Jump 1 would continue to the instruction immediately below it. Okay. Jump -20 would cause the instruction 20 lines above to be executed next. That's also straightforward. And then the last one, NOP, stands for no operation. It does nothing. Okay. The instruction immediately below it is executed next. Okay, so it's just an empty instruction. For example, consider the following program. Nope 0, ACC +1, jump 4, so 1, 2, 3, 4. ACC -99, so ACC now is -98. Then we continue to the next, -97, jump -4, 1, 2, 3, 4, jump -3, 2, wait, am I counting right? 1, 2, 3, 4. Yeah, ACC +3, Oh, so okay, so this goes on and on. Are revisiting this order. So 1, 2, 3, jump, we here, and then jump back. So if we jump back 4, it's like 1, 2, 3, 4. Oh yeah. And then we add accumulator by 3 again, and then we jump -3. We're here, add accumulator 1, and then kind of goes back. First, the NLP does nothing, then accumulator is increased, sets the next instruction to the other accumulator near the bottom. After it increases the accumulator from 1 to 2, jump 4 executes, setting the next instruction to the only accumulator +3. It sets the accumulator to 5. Jump -3 causes the program to continue back to the first accumulator. This is an infinite loop. Yeah, that's what I noticed. With this sequence of jumps, the program will run forever. The moment the program tries to run an instruction a second time, you know it will never terminate. Alright, so that's good to know. An instruction can only be run once. If it runs it a second time, then we've reached an infinite loop. Immediately before the program would run an instruction a second time, the value in the accumulator is 5. Run your copy of the boot code immediately before any instruction is executed a second time. What value is the accumulator? Okay, I think this seems pretty okay. First thought is we should be able to get this done in a fair amount of time. I'm going to grab the input, which is pretty long. I'm going to save it in my project folder. All right. Oh, let me keep this open. And it's in here. I'm going to remove the last new line. All right. So we have our input here. Let's have a look at it. So we need to go through the program and execute the commands as they are. And as soon as we find, as soon as we reach a point where a command has already been executed and it's about to be executed for the second time, we need to stop, and then we need to log the accumulator at that point in time, the state. So I'm going to have a global variable, or at least a variable that keeps track of the accumulator. And I'm gonna set it to 0. And as I go through this program, I'm going to adjust the accumulator, and I'm going to also have to account for the jump instruction to go to a different point in the array. So I'm going to split the input by new lines, which is going to give us an element for each line. And then I'm just going to go through them. Let me see what's best. Should I use a for each or a loop? I'm going to use a loop, an imperative loop, because I cannot break out of a for each method, and I need to break out as soon as I find that a line is going to be executed for the second time. It's going to be run for the second time. So let me call this boot commands, and then I'm gonna do a while loop. While how I'm gonna have to keep track whenever each command has run. What I could do is I could modify the command and like append an exit at the beginning or at the end. So then I can, on a second iteration, I can verify if the command starts with an X, then it's already run. That's something I could do to kind of like mark the line that, hey, this has already been executed. It can be whatever, doesn't matter. So I could just say let me see, am I going to do this in the while loop? I have the boot commands in here. When I have to create an I variable here that just starts at 0, and then while boot commands I starts with X, so it does not start with X, we can continue. And then here at the bottom, I'm gonna say that whenever we're done with this iteration, we're going to append X to the command. So let's grab the command here. Well, I'm gonna do it here actually. Let command boot commands, because then I could just reuse it in here. And then I'll have to boot commands I equals X plus boot commands I. This is kind of like append X to the command after we're done executing it. If I'm correct, boot commands is gonna grab that command, and I can't use command here because it's a copy of the actual command in the array, so that's why I have to tap into the array, and then I say X plus whatever. Yeah, this should be good, and then it's gonna stop here. Good. Okay, so let's go and see, let's first deal with the ACC command. So wait, we first have a line which is split by a space, so we can split the command with a space, and we're going to get an array of 2 elements. The first element is going to be the instruction. Let's see what they call it in here. 1 instruction per line of text. Each instruction consists of an operation and an argument. Okay, so we have operation and argument, and then if operation is equal to ACC, then we need to adjust the state with the argument, whatever the argument is, which can be a minus or a plus. So let's grab the operand by saying argument in here. So, and then we can say, where's the accumulator? Up top. Accumulator is if operand is equal to plus, then accumulator plus wait, let's grab the number as well, value, yeah, I say value argument slice here, grab the rest of the string, and let's typecast this to a number, so we're not adding strings to numbers because JavaScript cannot deal with that. We're gonna get ugly bugs. Accumulator plus value, otherwise accumulator minus value. There you go. So this should deal with the ACC command operation. Let's see, revisit this. So we've got the operation here. If it's equal to ACC, then we grab the operand and the value, and the operand is just the first element of that string, or let's just use slice here as well to be consistent. And I think argument Yeah, that's all right. Argument, and then we grab the value, so the number, and then we say, okay, if the operand is equal to plus, then we add the value to the accumulator, which is in here. And if it's not, then it has to be a minus. Then we subtract the value from the accumulator. Okay, and then let's also do jump operation, and I think the last one, if operation is equal to else, I think if it's not ACC or jump, then we can assume the operation is going to be NOP, because there are only 3 possibilities. So if it's NOP, then we just we don't do anything actually, so we don't even need this line. So yeah, let's see with jump. So what do we do with jump? Relative to itself, so kind of like jump to a different instruction. An offset from the, for example, jump 2 would skip the next instruction, jump +1 would continue. Okay, so continue. You know what I can do? I can do it in here, since we're done with this ACC operation, and then we have to continue to the next line. We say A++. Kind of like add 1 to the to I, and then in the next iteration we fetch the next command. In here, I is gonna be instead, I'll have to grab the operand as well. I believe I always need the operand, regardless if it's which instruction it is. So let me put this to the top, and then I can reuse that. I actually need to put this to the top as well, and I can say I is equal to, if operand is plus, then I is going to be, well, if it's like +1, it's just going to be +1. Yeah, so I can just add the value, and otherwise I'll subtract the value. Okay, this looks good. And then we change the command, and then we go to the next one. Shall we give it a spin? I'm gonna go and go ahead and log the results, see what we have, if it's something that makes sense or not. What are we logging? The accumulator. So the puzzle asks, run your copy of the boot code immediately before any instruction is executed a second time. So we don't need to execute the instruction for a second time, which this is gonna prevent us. Yeah. Okay, let's run it, see what happens. I was stuck in an infinite loop now, and I am, oh, might be, okay. It's still running for a very long time. I think it might be an infinite loop. Yeah, I'm gonna kill the terminal before anything crashes. Okay, so we reached an infinite loop for some, or it's just a very long program. Let me check the stop condition, because if we say the command, this command, append x to the beginning, and then starts with, well, command does not start with X, starts with, let me look up the documentation for starts with, see if it's indeed doing what I expect it to do. Determines whether a string begins with the characters of a specified string, returning true or false. So it returns a boolean, starts with X, well, does not start with X, then you continue, and then, it might just be a very long program. I'm going to, should I add a console log in here that kind of like logs the accumulator, logs the I, say I, accumulator, and then what else do we need to log? The command as well. Okay, let's run again. So I is kind of like increasing here all the time. Oh, something is definitely not wrong. The accumulator is not changing. All right, close. We found a bug somewhere. Let's see. I could just use the debugger. Let me try and use the debugger and be smart about this. I'm gonna add a breakpoint here. Okay, so what do we have here? First iteration, I0, command is ACC minus 8. Does that make sense? ACC minus 8. The operand is minus, value is 8. So if operation equals ACC, it does, so we should go in here. Let me add another breakpoint in here, and then continue. So now accumulator is minus 8. Makes sense because minus is not equal to plus, therefore we go in here, accumulator minus value. Yeah, so we already subtracted, the accumulator was 0 here, we subtracted 8, so we end up with minus 8. Oh, I think this is not doing what it's supposed to do. Yeah, this should be I plus equals 1. I think that's what's going on. Let's get rid of these breakpoints and add 1 in here. And go in the next iteration. Okay, so next iteration gives us I2, which is good. Accumulator, then we're not jumping to the next instruction, however, because our command is still ACC minus 8, and we should be here. We should be at jump plus 5. So that's where our bug is. We're not continuing. Let me check. Probably be because this is outside of the loop. Yeah, so I can't actually have it up top. It needs to be at the bottom. So I'm going to change this into a constant, and I'm going to access it. And then just do it like this. Yeah, this should work. Or if I can just, I can also be smarter about this and do it at the end. And like here at the end, command. Oh, wait a second. We're also appending X to the wrong command because I already changed here. So I'm going to move this to the top. After we grab the operation, the argument, then we modify the command. That's good. It needs to be, at least it needs to be before we do anything with the I. And then, so on the next iteration, command, because command is outside here, it won't change. So we need to change commands to be command equals to command to boot commands I, kind of like this. Yeah, let's stop the debugger, run it again. Let me add a breakpoint here, I guess. So it goes through first iteration, it's right. Yeah, then we go to the second command. Third, this looks much better. Okay, we're gonna get rid of this console log in here. Stop the debugger and let's run program again, see if we fix the infinite loop issue. We did, and we end up with 66 as the accumulator. I'm gonna try and see if it's right. We were lucky yesterday, we got our correct answer on the first tries for both of the puzzles. Let's see if the luck continues today. No, that's not the right answer. It doesn't say too low or too high, so there's no hints in this time. I'm just gonna go through the program with the debugger and see if it's doing the correct things. So for the ACC, let me grab the input here. Okay, so we have the input and the program next to each other. That's much easier. All right, so first line, we are here, operation, no wait, commands, ACC -8, good. We go to the next one, jump +5, so that's good. What's our accumulator at this point? It's -8. And then what's I? I is 6. We went in 6 steps. Is that correct though? +5. 1, 2, 3, 4, 5. I think that's good. +5 means, let me see, +4. So here they go 1, 2, 3, 4. Yeah, so you start kind of like 1, 2, 3, 4, 5. So next one should be ACC -17. Next command, ACC -17. Yeah, so we're doing the jumping right. If we're going plus anyway, let's see. ACC -17 should change the accumulator to be -25. That's also good. What's the command now? Jump 1. Is jump 1 correct though? Because we are at jump 1. We're here, I think. Wait, why are we at jump 1? That's not correct at all. Because we were at ACC -17, we should have gotten here. So that's where it went wrong. Let's see what I is. I is 8. Oh, I see. We're jumping far. Okay, we need to reset I to be 1. No, wait, I is 8. That's good. So 0, 1, 2, 3, 4. So just, Yeah, we're here. Okay, we're not something's wrong with the I. Let's see. I is 0, and so therefore we grab the first command, and then we change that command in place, so that's good. We don't need to just say here, yeah. So we change that command in place, perfect. And then here we increment I by 1, so that in here we access the next command, and then we go to the next command and so forth. So that's good. We increment I by 1, and here I is incremented by the value, by the jump value, or decremented. So I'm curious, let me add another debugger breakpoint here, because something's wrong with the with our I calculation. I'm gonna run the debugger again. Oh, so what's I? Is I in the global space or in the local? Local. I 0 on the first iteration, and then let's just remove this one. Now I is 1, therefore the command is, well, the command is jump +5, therefore we jump 5 steps, so we go to 7, which is good. Now I is 7, and we should grab, if I is 7, we should grab this command, jump +1. Oh yeah, that makes sense. Okay, I was looking at the wrong accumulator here. So jump +1 should go to I is 8, I is 8. So this is ACC -17, that's good. We go to this one. The accumulator is subtracted, so that's good. Then we go to I60, because we jump 51 steps. Yeah, so we're at 61, we're here. ACC +26, yeah, that's correct. No, everything seems good actually here. So the bug is not there. I wonder what I'm doing wrong. I'm gonna go back to the puzzle instruction and read it. Maybe I missed something. You narrow the problem down to a strange infinite loop in the boot code. You need to be able to run the code in isolation. The boot code is represented as a text file, 1 instruction per line. Each instruction consists of an operation and an argument. Oh wait, yeah, for the nope operation, nothing happens, but we need to like go to the next line. So we do need to do something either way. So it needs to be plus 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 or +1. I think it's the same. I think the bug doesn't here anyway. Yeah, I think we need to do that. So if the operation is not ACC or jump, we can assume it's NOP, no operation, and in which case we don't do anything. We just add 1 to the I, so then we can grab the next command. And I'm gonna try and refactor this out. should I? No, I'm gonna keep it like this. I'm too lazy to do it. Okay, back. Okay, now we got a different answer, and I think we got it right this time. Let's see. Yes, we did it. So the bug was in yeah, we forgot for the NOP operation here. If our program arrived at this point, then we did not increment I, and therefore it would try to, on the next iteration, it would try to run the same command again, and because we appended X, it's not going to run the same command again, and it's going to stop. So our program stopped whenever we reached NOP instead of continuing until we reach a command that has been run already. So that was the bug. We fixed it by adding I+1 for the NOP command, and we got the answer 1928, which is correct, giving us another star. We can continue to part 2. If you have any questions, by the way, it can be anything related to JavaScript or to the actual problem solving technique, let me know. I'll be happy to answer whatever question you have, or if you want to learn more about something that I'm doing or my setup or whatnot, let me know. I'll be happy to answer any questions you have. Let's continue to part 2. After some careful analysis, you believe that exactly one instruction is corrupted. Somewhere in the program, either a jump is supposed to be an NOP or an NOP is supposed to be a jump. No accumulated instructions were harmed in the corruption of this boot code. Okay, so we don't have to do anything with the accumulated instruction, but we need to figure out whether a jump needs to be a NOP or the other way around. The program is supposed to terminate by attempting to execute an instruction immediately after the last instruction in the file. Let me read this again. The program is supposed to terminate by attempting to execute an instruction immediately after the last instruction in the file. So when we reach this point, it should stop. So we need to reach this point, because if jump 1, so that says it's going to try to execute the next command, which doesn't exist, so therefore it stops. So that command is right anyways, but we never reach this part for some reason. By changing exactly one jump or one NOP, you can repair the boot code and make it terminate correctly. For example, consider the same program from above. If you change the first instruction from NOP to jump, it would create a single instruction infinite loop. Yeah, because it would jump to itself, never leaving that instruction. If you change almost any of the jump instructions, the program will still eventually find another jump instruction and loop forever. However, if you change the second to last instruction from jump -4 to nope -4, the program terminates. The instructions are visited in this order: 1, 2, 3, 4, 5, 6. After the last instruction, ACC +6, the program terminates by attempting to run the instruction below the last one, which doesn't exist. With this change, after the program terminates, the accumulator contains the value 8. Fix the program so that it terminates normally by changing exactly one jump to nope or one nope to jump. What is the value of the accumulator after the program terminates? Alright, that's interesting. We're going to at least need another accumulator to keep track of, and we'll name this part 2. And let me rename this one to part 1. And the only thing I can think of right now is to have a brute force approach, meaning just guessing. which is going to be quite time intensive, but maybe not as much as I'm guessing. So I'm thinking to just go to have the program go through each instruction, and whenever it reaches a jump or an NOP, flip those and kind of like remember that point and then continue the program. And then if it reaches an infinite loop, go back to that point in time, reverse the change, and then continue until it finds the next jump or nope, and then reverse it and then run the program. Does that work? No. Go back, change, continue, and so on until you actually found the right instruction that needs to be switched from jump to nope, or the other way around. We have 675 instructions in total, of which many are ACC, so we can say like a third of them are jumps and nopes, so 200 instructions or so to change, 200 different program possibilities, puts to go through. Yeah, I don't think it's gonna be that time intensive to run this solution. I'm thinking ahead as well if this is easy to program, or at least the most straightforward way to program, and if there's not something better I can come up with right now. What do you guys think, guys and girls? Let me know in the chat if you think this is a good approach. If you think there's a better approach, I'd be curious to hear about that as well. I'm open for any feedback, any input you might have. Let me see. Somewhere in the program, either a jump is supposed to be a nope or a nope is supposed to be a jump. Yeah. So for their example, they're kind of doing the same thing as well. They say if you change the first instruction, it would create a single instruction loop. So that's not correct. So then they go to the second. If you change almost any of the jump instructions, the program will still eventually find another jump instruction loop forever. So in their solution to this puzzle example, they're also taking kind of like a guessing approach. Hey, if you change this one, it doesn't work. This one doesn't work either. Same thing for this one, but for this one, the program is actually correct. So that's why I'm kind of like also thinking today take the same approach. I could also, or just thinking of this, I could also create a different program. So I will have to kind of like reverse the logic in here, but I could also start from the top and run the program in reverse mode. But I'm not sure that's easier. I think I'll still need to solve because the condition if you start from the top is you need to end at the beginning, because that's where the program starts. So you have the same problem. You also need to kind of like guess which combination, which switch of jump and nope leads you to the first command, which is the same thing as we're doing now. We need to find which switch leads us to the last command. So no, that does not actually make it easier in any sense. Yeah, I think I'll have to go with that. I can't find a better, so I can come up with a better solution than that. So let's program it. Let's program that. I'm going to move put commands here because I'm going to reuse them in the second step. So what are we dealing with now? Aside from running the program, so everything in here, We also need to have another like nested loop that runs a different version of the program when we switch a jump command to a nope, or the other way around. I'll just copy and paste this in here. Use accumulated parts tool. Yeah. Put this to the right so we have space. Let me think about this. Well, something I can't do is I can't change the commands in place, because then we'll need a fresh set. So I'm thinking to just make a copy of the boot commands. I'll still need to use a while loop though. Let me program it in here. I'm gonna say while boot commands I. Okay, so what we have in here is what I'm saying is, let me move this to the bottom. So what I'm saying here, if the command exists, then run as long as the command exists, and if it doesn't exist, stop. Which means we reach the end of the file, because we got here, and then which means it's good. This is our stop condition. This means that whenever we reach this, we found a working program. And inside it, I'm gonna copy paste all of this stuff, because we're gonna have a nested loop. So let's try and reason about this, how it works. While boot commands I exists, then we move this to the top. Then we grab the command, assign it to a variable, and then let me see, grab the command. I also need to gonna be making changes, so I need to know if it's a jump, then I need to reverse it. If it's not, then I need to leave it intact. So we're gonna need this part of the code as well to the top. And I say if operation equals jump, then what I need to do is change the operation and then continue. And then continue. But then if I reach in infinite loop, I need to come back at this point, change the operation back, and then go on. So I kind of like need to remember where I left off. need to remember where I left off. Well, if this outer loop is going to go through the commands, this inner loop, yeah, I can put this loop inside in here somehow. Let's first change the operation. What I can do is I can say boot commands. Oh, I made a typo there. Okay, boot commands I equal replace jump with NOP, and then assign this to, because replace does not replace the string in place, does it? And it returns a new string. Yeah, so we need to reassign it. Okay. Otherwise, this needs to be plural. But I'm changing the array here in place, which I don't want to do. Do I? Well, I could. Could keep it like that and just call it a function and then return, and if it's not, then correct the change. Let me see what's easier. Or I could just create a copy of the array, change that command, and then pass that into the nested loop somehow. Not sure about the approach. Let's do the other swap as well. So if we have nope, then just copy this and first these two. Okay. I could write this much in a shorter way though, in a one line. Anyway, do I want to modify the array in place? Let me think what's most intuitive solution. Yeah. If I'm here, we change this to a nope. And then we continue the program. So we go in here. Well, I definitely need a copy because I can't be adding X's. I definitely need to do this in a different, I need a copy. Yeah, I need a copy anyway. So I'm gonna make it. Let's make a copy here. We're going to say new commands. And copying an array in JavaScript can be as easy as this. Basically, you're creating an array with open and closing bracket, and then inside that array, you just structure a different array, this one, and you assign the new array to a new variable. So then you made a copy. There's also a method for it, but this just reads cleaner if you know what it does. So we have the new commands, and then new commands. I operation equals jump, then do this, and otherwise it's gonna get a bit long, so let me do it like this, otherwise do this. Yep, let's get rid of these lines. Okay, so we have the new commands, a new version of our program which we need to run into. So thinking out loud here, let's say, what if we do, so anything in here needs to be the new command, and then starts with X. I'll just say this. Okay, and then we add an X to it. So here inside this loop, we're operating on the new array, and then we go, so on the first iteration we have ACC minus 8. We do some parsing in here. Here we say we switch the instruction, which is not the case for ACC. So then I'll just do what it does in here. So we'll just go in here. But this conditional, well, let's see. It goes in here, and then it appends an X to this command, like this. And then it executes that command. So in this case, it subtracts the accumulator with 8. I plus 1. Here it grabs the new command, which we don't need. And it goes to the second one in here. So it should go here. But then, oh, it's not doing any of this though. Let me think. So we only need to enter this loop, this inner loop, if we find a jump, if we did the switch. If we did not do the switch, then we need to continue like normal. So this part needs to be up in the here. Let me extract this one here. So if you have a normal operation, you just oh, did I make a typo in here? Oh. Just continue, but otherwise, else, then we can assume it's either of those two operations. So we can actually have this one in here too. Copy one, you create a copy when we need it. So there, and then we can say put a while loop inside there. Okay, so we're also going to have an ACC command in here, so we need to keep this. So then we reach this point, and then we say we create a copy of the commands. Here we create a copy. This copy this copy will have not sure if I'm taking the right approach here. Well, the approach is good, but I don't think the nesting loop is what I want. Let me see. So we're at this point right now. We create a copy of the original array, and then we flip this command to an NOP, and then we have a nested loop. Inside that loop, we check for an X. It starts with an X, it doesn't. It adds an X, so then we mark that instruction as already executed. And we'll need to do that for the outer loop as well. We need to do that for the outer loop as well, yes. Let me see. I think I can just move this to the top and change this one to this one. There. Let's see, because we're doing this before we replace it. So this is gonna have X in here. We replace it, and then we just execute whatever's in there. But operation, we'll need to swap operation as well, unless we copy this part inside here, so then it rereads again. But then it's gonna mess up with the X, because it's gonna have an X jump and it's not gonna parse correctly. So I can either change the operation variable in here as well, so then it picks up the new operation, or I add the X at a different point, and I copy this command in here. So let's see. Well, imperative loops are so hard to read. This is already giving me a headache. It's so hard to follow the code, but I couldn't have done this with the functional programming, I think, or I didn't think long enough. Okay, I'm going to change the operand in place. Operation. If operation is equal to jump, then it's nope, otherwise it's jump. There, this can be a one-liner. This needs to be a let. All right, so we're x jump 5 here. We go into here, but then it starts with an x, so it's not going to be able to run that command. No, this is wrong here. We only need to add the x after we've executed the command. So it's either here or inside here. Or inside of there. We'll just add it here. I'm just going to copy it, and then I can always refactor it out if needed later. Else, and then I'll need a copy of this as well. The end here. Okay, so we're jump plus 5. We switch the operation, and then we run a nested loop inside this version of the program. And so it's ACC. No, it's not ACC. It's jump. It is jump. It's not jump because we changed it to nope. Right. We changed the operation here to nope. Okay. So then we go in here, and we just continue to the next one. So inside there, we're gonna have ACC plus 0. So it's gonna do ACC. Yeah. Accumulator part 1, that's not correct. Part 2. But then we're gonna mess up with our accumulator in each nested loop. So we kind of need to keep track of a different one. Let accumulator, or just the same one. Yeah. So this accumulator is going to have a certain value, and then inside here there's so many things I need to keep track of. That is very bug prone, error prone, because we humans are just bad at remembering a bunch of different variables and their states at different points in time. We're not good at that. Computers are good at that. But now I need to program in a way that I have to keep, I have to know what I'm doing, and therefore I have to think like a computer, but just too many things to keep track of. Accumulator part 2. We need to keep track of a new accumulator inside a nested loop, and then whenever we are done with that nested loop, if we reach the end of the program, then we need to log that accumulator, because that's going to be the answer. If not, we can discard it. But then we need to start off at wherever we left off in that loop. So we will need 2 accumulators. Accumulator part 2. Let accumulator later nested loop. I'm just gonna keep it this name. I can't come up with a better name. And I'm gonna assign this to whatever we have now. So inside the nested loop, we make use of this accumulator. And then I need to figure out a way to, if it reaches the end of the loop, I need to figure out whether it did that because it found an infinite loop, the program reached an infinite loop state, or if the program reached the end and therefore terminated correctly. I need to distinguish between those two in a certain way. Well, I do know that well, here I need to use a different I as well because I need to keep track of the I. So I'll name this, I'll create J in here. J is going to be equal to I, and then we modify J in here. Yep. J. Dealing with J here. Good. So and this needs to be J. So, but wait a second here. These needs to be new commands. So we're executing that line with the new operation, and then we mark it as already executed by saying new commands, by appending an X to the command within the new commands, not the old ones. So that's good. And then we go on to the next one, which is here it needs to be J. Go on to the next one. Then we do the same thing. No changes though. We continue until finds an infinite loop, or it terminates. So it reaches. It can also reach the end of the program here, in which case J is going to be the length of the array, or +1. Then we kind of out of bounds. So what we can do is, so while we have not executed a command, or J is within, so it's smaller than new commands dot length, or I can just do this actually, the same we did up top. Then instead of I, it's going to be J, and instead of boot commands needs to be new commands. There. Then we reach the end, and we verify here. We kept track of J, so we can say if J is well, or same thing here. So this basically tells us we reached the end of the program because there's no new instruction anymore. We are at +1 here. So if that's the case, we found our answer. So we can console log the accumulator in the next nested loop, because that's the accumulator we're looking for. Answer part 2. And then we need to break out of this loop. So how are we going to break out of that loop? Well, okay, let me think about a different case. In case we reached the an infinite program loop inside this loop, then what happens? Then this is gonna be false. This is gonna be false. So therefore, we are going to continue with the iteration in the outer loop. So it's gonna go back again. It's going to let's go back to the first instruction. So we were jump +5. It ran the program, the different definition of the program with nope.5+5. It found an infinite loop. So it exited. So then we need to kind of like have to add to mark that we executed the command. We need to do this at the bottom here, and we need to kind of like do this part. If operation is equal to jump, then we modify I. Okay, and then remember we changed the operation here, so we need to swap it back. Or we could just say new operation. But is that's gonna mess up with... Oh wait, something I'm not doing inside here. Every time I'm not grabbing the operation again. Okay, so I need to actually copy paste this code inside of here. In which case I don't need to change the operation because I'm grabbing it in here anyway. So yeah, I can just get rid of this line. New command, I'm swapping there. Okay, so in here I'll just grab commands as well. It needs to be side. It needs to be new commands. I can just say commands already fine. So let's say command nested. Best name I can come up with right now. Command nested. There we go. So command nested, operation nested, argument nested. Everything needs to be nested. This is the worst naming I can think of, but it makes sense to me, at least for now. Operation nested, so I'll need to kind of like replace all of these. Value nested. So then I can also like rename to have them all be consistent. Nested, and then operation nested, operand nested, and then value nested. There we go. Yeah, and then the command command nested. Yeah, new commands, and then kind of like need to do this as well, don't I? Because we faced that in the previous run. Yeah, I can. Where did we reassign command? starts with X, command split, and then, oh, and then, okay, good, yeah. So we can do it in here. But actually this needs to happen before we do anything with X, though. Yeah, we need to mark it as executed before we do anything to it. That's tricky because we already incremented it. I'm sure this has a ton of bugs and it's going to be a hell of a lot difficult to debug this imperative logic. How far are we into the stream? 1 hour 23 minutes. Took quite some time. Let's deal with bot there. Okay. If you're watching now, at least say hi, so I know you're here, keeping me mental support. Kind of struggling today, day 8. I should have said that it was too easy this year, because now I get what I'm wishing for. Something really hard to reason about. Okay, back in our logic, really deep thinking here. So I mark the command inside the command as executed, and then I do whatever I need to do, and then we can just say kind of like here, so like reassign the new command. So reassign the command nested with the new command using J. Only use J inside here. Okay. Okay, so this looks fairly decent. Why is this variable not used? Argument nested. Argument nested. Don't I need to use that? Argument slice. Oh, here. Okay, argument nested. Okay. All right. Does this make sense? Let me go over it again. Command nested. So here up top, we do some things. We say the accumulator, we start with an accumulator that's from the outer loop, and J starts at 0, and then we grab the command, which is, no, is not this command, should be this command. Yeah, which we swapped in here. We swapped it in here. Okay, and then we have the command. It starts with X. No, it doesn't start with X. Well, or yeah. We go inside here, operation, and the argument. We grab the operand and the value, and then we mark it as executed. Wait, this needs to be equal to I. What am I doing here? This needs to be equal to J. Yeah. Okay. Mark the command as already executed, and then if the operation is equal to ACC, yeah, that's good. We adjust the accumulator by saying if it's plus, then we add the value. If it's minus, we subtract the value from the accumulator nested. So that's good. Otherwise, if the operation is jump, then, and we add 1 to J, so that in the next iteration we grab the new command, goes in here. Okay, that's good. Yeah. And then if the operation is jump, if it's plus, we add the J with the value, otherwise we subtract J from value, and otherwise it's a nope. So we go in there. It's good. This should exit at some point. let me add a comment. Program executed successfully, because the command is out of bounds, meaning we'd reach the end of the program. But then we can also do like this. If there's no command, yeah, then we can log the console log the answer. In here, program encountered a nested loop. So program had a nested loop. Wait, kind of like need to break here, don't we? Break. I need to break here because so then I break out. Oh, I'm not sure if that does what I need to do. Okay, so in any case, the program, when a program found a nested loop, well, the inside loop found that encountered an infinite loop. I must say an infinite loop. When the nested loop found an infinite loop program, means we did not have the correct switch of operations. So therefore, we just continue with a regular execution of whatever we had. Let me verify that we're not messing with the operation here. No. So if operation is jump, then the operand needs to be that. We increment I, and then we mark it as executed. We only mark it as executed here, which is wrong because we already incremented I. So we need to do that in here, as we do for A. We already incremented I, so that's going to be buggy. We need to do it here. Actually, let's make this here, just here. We execute a program, we mark it as executed. That makes sense. And then we increment I. Let's do the same thing here. We yeah, like this. You don't copy pasting here. I'm not exactly try, but it's easier to reason about. Actually, no, I can just stick with one. Yeah, I don't need two of them. Yeah, because there's nothing to execute. For jump, you just jump at a different instruction. So this needs to be at the top. That's good. Put commands. I'm using I. Great. And then the outer loop needs to continue. If inside if else here, the outer loop needs to continue. There's a bit of construction noise outside. I apologize in advance if that's too loud. Perhaps you can't hear it all, which is great. I'm hearing it a little bit. So then the program needs to continue the outer loop, and then it grabs the new command. So let's just follow the same logic as here. Let's just do let's move this up and say yeah, and then say command in here. Replace it with whatever. And then at the bottom, I kind of like need to change to copy the same thing. Very at the bottom, we say for the next iteration, use command, this command, which is going to be our next command. Yeah, so use the next command for the next iteration. And then we continue until, well, we continue until until we reach this point. Actually, we need to stop here. But let's say we did not. So okay, we continue, and then in the second iteration, we're gonna have same thing. We add to the accumulator. And we mark the command as executed, or otherwise we swap commands. Here we create a new array. We have a new accumulator nested. Okay, that works fine. Yeah, we kind of need to break out here. Yeah, which we do. We break. This break is gonna exit this loop, I think. Wait, is it highlighted because it says that it's that loop? Let me add a break inside this loop. Let me double click it. Oh yeah, whoa, that's smart. So I can just like, yeah, this tells me inside which loop is gonna break. Nice. Yeah, so this breaks the outside loop, so we're good. We're never gonna get to this part if we found an executing program. So that's good. A successful program, I mean. Yeah, successfully executed program. So do we need any of this stuff? No, we don't. Nope. Yeah, and then we just wait. We need to log the accumulator nested. Okay, I think I'm pretty confident. I want to give this a spin, see what it does. Yeah, let's run our program. Fix some errors that we get as well. Has already been declared. Oh, probably be because, yeah, we have I here as well. Let me rename this to I part 2. I part 2. Oh, it's not gonna rename. Oh, I'm reusing I in a bunch of different places. I could just wrap everything inside a function. Yeah, let me just wrap everything inside a function because I'm using I everywhere, so I have to rename it in many places. Function part 2. So it has its own scope in here. I can just wrap it in an IV immediately, which stands for immediately executed function evocation. So just do like this. Yeah. So then we shouldn't have any conflicts with the other variables here. So I can just stick to their original name. Accumulator here has a different scope, so it's all in here. We do need the nested. Yeah, we do need to distinguish between anything that's a variable that's here and that's in the auto scope here. Okay, let's run again. See if we solve the error. We did, but we have a different error. Starts with undefined, line 54. Starts with, okay. Of course, because we did find a correct program, but it's gonna try and say it's undefined. So let's say while command, I need to short circuit it by adding it to the top. While command nested and so while there exists a command and the command does not start with X. Okay, that sounds better. Okay, we seem to have a successfully running program and we get an output value of 1232. Shall we give it a try and see if it's correct? I highly doubt it because I can't even wrap my head around fully what's going on in here. Not the right answer. Okay. It doesn't say too low or too high, so we don't get a clue about that. We'll just need to figure out. What we're doing wrong. Yeah. Should I bring it out to debugger again and go through each line? Where should I add a breaking point? I'm gonna add a breakpoint here, and let's run the debugger. So we have a few variables here. First command here is x acc minus 8. Accumulator is 0. Why is accumulator 0? Shouldn't accumulator be minus 8? Let me add a different breakpoint in here and rerun. It doesn't, that's weird. It doesn't grab the operation. Command split. While true, I'll just say true here. While true command, so the command is oh wait, we're already modifying the array here, aren't we? Yeah, we need a new copy. We need a new copy. How are we gonna do that? Yeah, what I'm gonna do is I'm gonna wrap this inside an immediately executing function as well. Because our solution for the first part is messing up with the array in the second one, because it already marked them as executed, the instruction as executed. So it's we need to start with a clean array. So in here, what we're gonna do is we're gonna create a copy const can just keep this name, actually, boot commands. It's going to be a copy of instructions. I'm going to rename this instructions. Or let's just say boot instructions. So we have boot instructions, and inside here we copy it into boot commands, and then we use boot commands to do whatever we want. So let's do the same thing in here. Okay, so that should give us a clean slate for each part. Let's run the debugger again. Kind of went, let's add a breaking point somewhere. Let's add a breaking point here. True, while true. I'll add in here. Did it find an error? Yeah. So the debugger doesn't complain when it finds an error. Interesting. unexpected token. Of course, there should be a space here. Why is this still expression expected? Oh, of course, wait, I should, no, that's not it. Here, what do we have here? We have oh, this needs to be another bracket like this. Okay, this should be good. Accumulator is not defined. Line 32 here. Oh, of course, let's move this up a bit in here. Okay, this should be fine. We wrapped our solutions in functions. We get a different result. Which might be because we just because we're dealing with a clean array now. So the first time we tested, we were using the commands from the previous part, and those were already altered with X in front, marking them as solved or not. So it would give us a different answer. So yeah, because it was not using clean input. Let's see if this answer works. It does. Yes, we did it. Yeah, so our solution was just right all along. There were no bugs in here. Let me make the code a little bit bigger in here. We can get rid of this. Yeah, so our solution for the second part, it was correct, but we were using already modified array from the first part. So we got rid of that issue, and then yeah, this works. I have no idea what it does, or a little bit, but I'd say I can't fully wrap my head around it. And it's very ugly and verbose. I think this is the longest solution I came up with so far, but it works. Yeah, really happy about the result. We got the star. We got 16 stars now. Yeah, and the map evolved a little bit. We're still in flight. Good. We can wrap it up. I think. Let me just push the solutions to the repository so you can have a look later on. Git status day 8 solved. Git push origin main. So I've uploaded the solution to my repository where I keep track of the solutions of every day. If you want to have a look, I'm gonna paste it in the chat for your convenience. And yeah, I think we can wrap it up for today. Thank you for joining. Appreciate it, for keeping me company, and I hope to see you tomorrow for day 9 of Advent of Code, same time, 10 a.m. Central European time. And if you want to reach out to me, I'm available. You can find me on Twitter, maximization_. I'm gonna link it in the chat as well. Feel free to add me, send me a message if you want to talk about Advent of Code or just JavaScript, programming, anything. My DMs are open and I read all of them. Yeah, thank you very much, and I'll see you tomorrow. Bye bye.